Chapter 2.7, exercise 1 through 6. And section 2.7 has to do with solving rational equations, which are equations with a fraction, rational meaning fractional. And here we have exercise 1 through 6, solve the equation algebraically, support your answer graphically, and identify any extraneous solutions. And so we have three steps here: algebraically, support graphically, and identify extraneous. We're going to understand what extraneous means. Now, to solve, and if you just look at this equation, you could see that everything is divided by 3, and so we know that x minus 2 plus x plus 5 has to equal 1. But just conceptually, to see what's going on, we're going to write this whole equation out, which is x minus 2 over 3 plus x plus 5 over 3 is equal to 1/3. And the technique we use here is called to clear out, I'll just put clear the denominator. Denominator. I think that's spelled correctly. Okay. And specifically, this denominator, we have 3 in the denominator. So if we multiply this entire equation by 3, what do we get? Well, we're going to get 3 times x minus 2, and I'm going to put x minus 2 in parentheses, plus 3 times x plus 5 over 3 equals 3 times 1/3. And what we have here is cancellations. We have 3 over 3 cancel equal 1, 3 over 3 cancel equal 1, 3 over 3 cancel equal 1, and what do we have left? Should be to our surprise. We have x minus 2 plus x plus 5 is equal to 1. And combining like terms, we have x and x, so we have 2x, and negative 2 plus 5 is going to be plus 3, and equals 1. We subtract 3 from both sides of this equation, and we get 2x equals 1 minus 3, which equals negative 2, and we divide both sides of this equation by 2, so we end up with x equals negative 2 over 2, which equals negative 1. So that's step 1. We solve the equation algebraically, support your answer graphically, and for that we go to the graphing calculator, and as it happens, I entered this equation earlier. Now what I did, a lot of people, when they solve graphically, they set one side of the equation equal for one function and one side of the equation equal for another function. What I did is I took that equals 1/3 on the right and subtracted. When you go ahead, what you're doing effectively when you do this is you're setting one side of the equation. If you subtract 1/3 and set the function equal to this, we're setting one side of this equation equal to 0, and I'm going to show in more detail later on. Then we press enter, and we see right here at negative 1 the line touching the graph at x equals negative 1. So that is a graphical confirmation. And then extraneous solutions. Okay, and having done a graphical confirmation, we're going to go ahead and extraneous solutions. Now, extraneous solutions are solutions that are created during the process of solving algebraically. And so we don't see any extraneous solutions. This is a real solution. So we say no extraneous solutions. And I think later on we're going to get at least one example of an extraneous solution that said, okay, next, on number problem. which is 3. And we have the rational equation, x plus 5 equals 14 over x. So I'm going to rewrite this. Okay, and for this, we are going to clear out the denominator. And what's in the denominator? X. So if we multiply this whole equation by x, we're going to have x, so we can distribute to each thing inside the equation. So we have x times x times 5, and x times 14 over x. So we're going to have x squared, which is x times x, plus 5x equals 14. I'll just put x times 14 over x. And this will cancel here, x over x. So we end up with x squared plus 5x equals 14. And we can solve one side of this equation for 0 by subtracting 14. So it really, from both sides, so it really becomes like a solving a basic quadratic equation. Let's get minus 14 here. Cancellation, so we have 0. We have x squared plus 5x equals, oops, negative 14. Let's see, minus 14 equals 0. And we're going to try to factor to solve it. We can use quadratic formula, but I think I'll just go ahead and draw a box over here. Okay. Whenever I'm rusty with factoring a quadratic trinomial, we'll put x squared in the upper left, negative 14 in the lower right. So your factors of x squared are x and x. We know that. So we have x, x. So x and x. And then we need our factors of negative 14. Well, 14, what are the factors of 14? 2 and 7. So if we have 2 and 7, and we need to have this plus 5x, right? So this 7 has to be plus, and the 2 has to be minus. And so we have minus 2x plus and 7x here, and together these add up, 7x minus 2x add up to 5x. So factors are going to be x minus 2 times 20x plus 7. And solving this equation, we have x minus 2 equals 0, and we have x plus 7 is equal to 0. And solving for x, we have x equals 2, and x equals negative 7. And it says support your answer graphically. So we're going to go support answer graphically by going to our graphing calculator, and we're going to enter equation, Control I, get a new page, add graphs. We have x plus 5, and we're going to subtract that right side of the rational equation. So we're going to, instead of setting two equations, the left side and the right side, we're going to subtract 14 over x. What I'm doing right now, solving by graphing, is a neat little trick. See, we're subtracting this 14 over x on the right side and getting this thing all in a single function. So we graph the function, and we see graphically over here at x equals negative 1, negative 2, 3, 4, 5, 6, 7, we have negative 7, a solution, and positive 2, which confirms. And we go and box in our answers here. And these are, we confirm graphically, these are real solutions. So we say no extraneous, right, no extraneous solutions. Okay, we go on to our next unknown problem, which is 5. And we have this more complicated equation. So x plus 4x over x minus 3 equals 12 over x minus 3. So I'm going to rewrite this equation. X plus 4x over x minus 3 equals 12 over x minus 3. And we're planning to clear out our denominator, and to do that, we multiply by this common denominator, which is going to be quantity x minus 3. And so just multiplying these things together, we have x, I need to leave myself some room, x times quantity x minus 3 plus 4x times x minus 3, and we have this 4x over x minus 3. And then equals 12 times x minus 3 over x minus 3. And what do we have here? We have on the left side, x minus 3 over x minus 3 cancel equal 1. On the right side, x minus 3 over x minus 3 cancel equal 1. And we have left, we're going to have x times x times negative 3. So we're going to have x on the left, x squared minus 3x and plus 4x equals 12. And combining like terms, on the left side we have x squared plus x equals 12. And solving the right side of the equation for 0, if we subtract 12 from both sides of this equation, subtract 12, we have x squared plus x minus 12 is equal to 0. Okay, and factoring, what are your factors of negative 12? Well, negative 4 and 3, or negative 3 and 4. Right? So we have a plus here, so we have 4 and 3. The 4 is the bigger number, so that's going to have to be plus, and minus 3. So those are your factors, and if we multiply these 4x, we get 4x, and then 3 times negative 3, so that's going to work out. If we multiply these two factors below together, we're going to get x squared plus x minus 12. And just coming up here, we have x plus 4 is equal to 0, solving. We have x minus 3 is equal to 0. And if we have x equals negative 4, that's one of our solutions, and x equals 3. So let's go ahead and graph this, and we're going to do the same process we did before by taking on x plus 4x over x minus 3 minus this right side. So we go to our graphing calculator, Control I, add graph, and we have x plus control fraction 4x over x minus 3, and we're going to subtract that right side of the equation here. So we have minus fraction 12 over x minus 3. And just taking a glance back at our equation here, we are subtracting the right side of this equation. And so we press enter, and we get a solution at -4. So this is a graphical confirmation. Do we see that solution of 3 anywhere? No. So 3 is an extraneous solution, a solution created in the process of solving the equation. So I'm going to show you another way of doing this. So these are both solutions, but in this case, x equals 3 is an extraneous solution. There's another way we can test for extraneous solutions is plug back in to the original equation. Well, look at this. If we plug 3 into the original equation, we have 4x over 3 minus 3. What's 3 minus 3? 0. So essentially, if we plug back in the 3, this function is undefined and hence unsolvable. So that's sort of a logical explanation of why that's an extraneous solution. So anyway, those are your problems 1, 3, and 5. Good luck on solving your even number problems as a demonstration of your learning, and thanks for viewing.